In other videos, I discuss this much more in depth, but these are some quick ideas, an overview with some more concise things and added for space-based disasters that could affect all of humanity. The first thing I want to go over, and I'll link to some of my previous videos on it, that more in depth, is about asteroids crashing, and or meteors or comets, whatever you want to call them. I know there's a difference between the things. But here's some ideas to prevent it from wiping us out or just really harming us. The first idea is to make it so that the asteroid crashes somewhere else, and maybe we can clean up the field that way. The moon, Mars, gas giants, and so on. Now, the problem with the moon or something is that the moon doesn't have as much gravity, so stuff might flung off and re-land on Earth. You know, you could argue that maybe that's less bad because they're small pieces will likely burn up, or maybe it's worse because it's more debris scattered over a larger area. So for the moon, at least, we would have to do a lot more calculations to see if it's safe or not, and a lot more understanding than basic moon. But it's also one of the easier options for last-second effort because it's closer. Another idea I've had is to use gas push, which I say instead of pushing it with a hard impact, we have some gas bubble that explodes or is pushed out that pushes a meteor or comet, something which can take care of pushing something that's lighter and looser, that no more hard impact will scatter, and then all those little individual pieces will hit Earth. This way it's a more of a central push that still is equally strong but spread over a larger area. A similar idea I've proposed is an inflatable push device, so you inflate a giant thing to push it that can, and we can fit stuff in packages that are square miles to really gently push it out of the way with more force, but the force is spread out, and that because it's inflatable, it can also shape to the right shape of the material. I talked about also developing more telescopes, and if we make these telescopes also based for space communication and other uses, it becomes more doable for us to put a bunch out there that might not be as high quality because they have other uses and the data adds up, and it might be more useful to get people on board too for this whole thing. Another idea is to put in outer space cannons and stuff to deflect it on the moon or something, and then we can launch high-speed vehicles quickly without having to worry about Earth's atmosphere to a apocalyptic scenario. These space cannons also could have huge solar fields, and if it's on the moon, not only is there less atmosphere, but there's also less gravity for us just to deal with anyways. Actually much less gravity. But yeah, you can't hit it from all different directions and so on and so on. Another thing is, for all the studies, so you might also have to do an inspection of the actual moon. And what I mean by an actual inspection of the moon is because if we're going to crash anything into the moon or launch anything from the moon, we have to know more about the moon's actual chemistry. So promoting these studies as part of the studies to learn about the moon might also get more people interested in this whole idea. More time funny. Another thing is to develop better simulation of gravity in the solar system, so we know how much we have to nudge stuff in certain different ways for it not to impact us, or what will impact us with better models. And this is both from a theoretical standpoint about making better computers and simulators and getting the power for that, because believe it or not, that's super complex because of all the interplay of objects, and we don't have enough computing power, so you oftentimes have to take shortcuts, and we also don't know everything in the solar system to a less theoretical, where we're inspecting and looking around the solar system from objects. If we can detect the movement of objects better in the solar system, how they're moving, we can try to fill in the blanks a lot better and make better predictions. Or we send out actual probes and out and see how they move in orbit and use that data to help simulate it. But we also may not need only gravity simulation. There's also stuff changes its center of mass because it thermally expands or contracts when it gets near the sun. It injects particles, especially comets, which can change trajectories of it because it's acting kind of like a rocket, but also changes the center of mass and stuff like that. And other than small particles. So also making simulations that take cat account, but that's going to be quite hard because you have to know composition of that. So inspecting more different types of asteroids and stuff might be a key to that, but also just we have to have a lot of things out there for the last second disc efforts to really detect stuff that's more unpredictable. The smaller the object, the more unpredictable it is. That's less concerning, but still a big concern. And that's kind of what I meant by 6 quick inspections, which I kind of skipped over. Another major problem happens to be solar flares or other solar radiation or storms that can cause wide amount of particle radiation and magnetic fields and stuff like that that can knock off modern day electronics and cause widespread disaster. But there might be some simpler things we could do. Maybe building more Faraday cages around certain structures or ways of interrupting it. Faraday cages are a way to prevent radiation from disrupting magnetic things from electrical magnetic equipment, and simply a metal cage or metal conductor structure around something with an insulator in between, and through the metal there's no current flowing through it. And oversimplified is the electromagnetic radiation kind of gets trapped on the outside, so it isolates the inside. Another thing will be to develop better warning systems simply, so it understands weather, and these will also develop new instrumentation for radiation detecting stuff could be useful on Earth for studying molecules and cancer and imaging. And these new computer models could be also very useful in computers. Having more small scale grids that are not always fully connected might be better because the whole thing might not blow up as much or might be easier to fix if something goes wrong. Having what I'm going to call photonics, electronics, and stuff like that might be better because it might be less sensitive to blowout. And photonics is using photons to compute instead of electrons. It's not there yet, but there's some advances in that. Theoretically, it could be low power. You could do multi-channeling where you could have one transistor or something with a photonic equivalent that use multiple different types of beams of light at once. So it computes in red and green. It's like double the amount of computation one thing can do or more. Or use polarization where it's light is going up, some light is going up and down, vibrating, the light's going side to side. If you have fiber optics and everything, you don't have to convert between light for computation, electricity to back to light. This could save a lot of time and make the thing work better with less loss of information and stuff like that. It's efficient there, cooler. But right now, we really can't make enough the pieces tiny enough of them right next to each other to really make it useful. And maybe also having a system with better circuit breakers in isolation features so the whole thing doesn't blow up as much, or is more easily recoverable. And beyond circuit breakers and stuff, maybe having small grids, because big grids, what happens is as oscillations can build up, and the bigger the grid, the more they can build up. So small things might be less sensitive to solar radiation and flares. Now the final one stuff were out there, but making us more of a multi-planetary species might help us survive any upcoming crisis. Also, it's engineering humans to be more resilient or something. Same with food or something, crops. making habitats that are more resilient and stuff like that. That's more futuristic and out there. And we could arguably start right now. Well, thank you very much for listening. Please like and subscribe. It really helps a 10 out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with help, I think I can do it. So if any ideas for future videos, comments, or suggestions, please leave in the comment section below. Again, thank you very much. Goodbye.